Okay, so in section 4.2, there's not going to be any new materials learned or new concepts. Basically, we're going to be taking all the material we used in section 4.1 and putting them to use in graphing polynomials. So I have about 6 examples to show you. These are going to be very similar to the examples that you'll be seeing on your homework. Okay, where I'll ask you about end behavior, intercepts, and zeros and multiplicities, and putting all this together for a graph. So the key to do this is making sure that the polynomial is in factored form, because if it's in factored form, you can basically read off the zeros, which we know are the same thing as the intercepts. But before we do that, let's look at this first example. What would be the end behavior? Well, for the end behavior, we look at what is the leading term. And we can see that if we were to multiply all this out, the highest power of x would be x times x times x, which is x cubed. Okay, plus some other things, right? So x cubed is the leading term. And that means that f of x behaves like x cubed, okay, as, let's say, the absolute value of x goes to infinity. We're just using this because that's saying when x gets large in either the positive or the negative direction, okay, and behaves like, we're talking about the graph of f, behaves like the graph of x cubed. All right, next is what would be, let's see what the zeros are. And we can see the factors are x, this is x plus 3, that's the same thing as x minus negative 3. So negative 3 is a 0. X minus 4 is a factor, so that means 4 is a 0. And we can see x minus negative 5, so negative 5 is a 0. Okay. And because these factors occur exactly once, the multiplicity of each is 1. Okay. This means that means at each point the graph will cross the x-axis. The x-intercepts are precisely the zeros. X equals negative 3, 4, and negative 5. And the y-intercept, well, what would that be? Well, remember, how do we find the y-intercept? We plug in x equals 0. And if we plug in 0 into here, we get 0 plus 3, 0 minus 4, 0 plus 5. If we multiply this all together, we get 3 times negative 4, that's negative 12. Negative 12 times 5 is negative 60. So the y-intercept will be at negative 60. All right. Then we can put all this together and see what the plot the x-intercepts first. So here's negative 5, negative 3, and positive 4. And because the graph is behaving like x cubed, remember that starts down here, it ends up here, and we're crossing at each x-intercept. So it looks like that. I'm not actually drawing this to scale because this should be negative 60, so it should be much further down. This is negative 5, negative 3. And 4. Okay, and we can see that we don't exactly know if the turning point is right here at negative 60. It may or may not be, but we can see that we have 2 turning points right here. All right, let's look at the next example here. Let's first find the leading term. If we were to multiply this out, we get x squared. But then we'd have multiply it by 2 times minus x. And because of this minus sign, we can see that the leading term is going to be minus x cubed plus some other stuff. So f behaves like minus x cubed as the absolute value of x gets large. And what would be the zeros? Okay. Now here we have 2 minus x. We don't have x minus 2, but in fact we have the opposite of x minus 2. So we actually can rewrite f of x, if we want, as negative 1 times x minus 2 times x plus 5 cubed, or squared. Right? Basically, we can factor out if we multiply negative 1 times x minus 2, we get negative x plus 2, which is the same as 2 minus x. Okay, so the x minus 2 is still a factor. It's just a little hidden. And so the zeros will be 2 with multiplicity 1 and negative 5 with multiplicity 2, because x plus 5 occurs twice. Right? Then that tells us that we're going to cross at 2. The graph will cross at 2, and the graph will touch at negative 5, because the multiplicity is even. And the x-intercepts will be at x equals 2 and x equals negative 5. The y-intercept, well, if we plug in x equals 0, we get 2 minus 0 times 0 plus 5 squared. This is going to be 2 times 25, which is 50. So the y-intercept will be at 50. And we can now graph this. The x-intercepts are at negative 5 and 2. This behaves like y equals minus x cubed. So that means when x is negative, this is actually going to be positive. So it starts up here. It's going to come down at negative 5 and touch. And then it's going to hit the y-axis at 50. And then it will go down and hit cross the x-axis at 2 and continue down. Okay. Again, we don't know where this is actually going to turn around. It might not turn around at this point, but we know it might be like something like that. But that's what the graph will look like, approximately.